This is our Grove LCD screen. There are various models, various options that are available. So it's a 16 by 2, which means that there are 16 columns and 2 rows on this display. It's Grove because of this white connector on it. Some options have pins that come out directly. So to use it with the maker board, I'm making use of a Grove cable. So this cable has pins at the end. The pins are either male or female. In this particular example, I'm making use of a Grove to male connector. Right now, you'll see that there are 4 pins labeled from top to bottom: ground, VCC, SDA, and SCL. The ground is the black cable, the VCC is the red cable, the SDA is the white cable, and the SCL is the yellow cable. So on the other end, I've connected it to our Arduino Maker Wi-Fi. And what I've done here is you'll see that the black is connected to ground, the red is connected to VCC, and then we've got pins 11 and 12 that we're making use of. Let's try and get a better view of it here. So we've got pins 11 and 12. Our white cable is connected to pin 11 and our yellow cable is connected to pin 12. Right. Now, we've already uploaded the sketch to the Arduino, and once I power it up, you should see our output on the screen. And then once we're done here, we'll go and take a look at the sketch itself and discuss our code. Okay, so here we have it. The sketch is running on the screen, and we have our hello world of embedded. Okay, so let's go take a look at our sketch. Let's take a look at the sketch that is required in order to print out to our LCD. The first thing you want to do is go to your library and search for LCD 1602, and we've got this RGB LCD 1602 from DF Robot. Go ahead and install it if you haven't already, or update. I already have it installed and I'll just leave it that way. Next, you can go ahead and compile and upload the code. So let's take a quick look at our sketch. On line 1, we include that library. And then on the next 3 lines, lines 3 to 5, we define values for the intensity of the red, green, and blue channels. And that will define the color on our LCD display. In this particular case, we want it to be strictly blue. So we turn off red and green by setting those values to 0. And then we want blue to have maximum intensity, so we set that value to 255. On line 7, we instantiate our LCD object, and we need to specify the number of columns and the number of rows so that it will function properly. In this case, our display has 16 columns and 2 rows. Next, within our setup function, which starts on line 9, we initialize our LCD object, and then we set the color using the set RGB function on line 11, which takes our red, green, and blue values. And then on line 12, we call a custom function called print_LCD that takes 2 parameters. Both of them are string values. The first one is hello world, and that prints to the first row. And then the second is of embedded, and that prints to the second row. We don't do anything within our loop function, so we don't keep updating the LCD. We don't need to do that. Let's jump to line 19, where we define our print LCD function. We can see that there are 2 parameters, L1 and L2. Both of them are string values. What we do is, first of all, we clear our LCD display, and we do that on line 20 using the clear function. And then on line 21, we use the set cursor function that takes two parameters. The first parameter is the column number, and it's 0 based. So we set it to 0, and that sets it to the first column on our display. The second parameter is the row value, which is also 0 based. So 0 will set it to our first row. And then on line 22, we use the print function and we pass in our string value, which is L1, and that gets printed on the screen. And then on line 23, we use set cursor. This time around, we set it to the first column, but the second row. Remember, we're using a 0-based index. So we use column 0 and row 1. And then on line 24, we use the print function again to print out the second parameter to the second row. And that's it. You can go ahead and compile and upload the code to the microcontroller. We've already seen it in action. Thank you. In this project, we're going to make our code modular. This is useful for separating out lots of code from our main sketch file. So to do that, we're going to go up here, click on it, and then click on New tab. And then we can specify a name. Since we're working with our display, we're going to call this display.hpp, and that's our header file. Click on OK, and you'll notice that there's a second tab up here, and we have our display file. We need to add some code to the header file. I'll go ahead and paste in the entire code and then explain it. So here's what the code on our header file looks like. On the first line, we have this pragma, and that's just an instruction to the compiler to only import this header file once. Then on the third line, we have this instruction to include our Arduino header file, our Arduino library. Then we have a namespace. And what the namespace does is it avoids naming conflicts for our functions, our constants, and our variables. And what that means is we can have multiple libraries with the initialize function. And once we make use of our display namespace, we know exactly the function that we're trying to address. Now you'll notice in the header files that we have function signatures, but there are no definitions. Now we need to add the definition for this. So we'll go ahead and add another file. And this time around, this will be display.cpp. And we click OK, and that saves it. And then we need to add code to display.cpp. And this is our code. On the first two lines, we include our libraries. Line 1 has our display header, and that brings in our definitions. And then line 2 brings in the LCD library that we need to work with. On line 4, we define our namespace once again, which is display. On line 5, we initialize the LCD as we did previously. On line 7, we define our initialize function. So we go ahead and give it a body. And so we do the two things that we did in our previous code in the setup function. So we initialize our LCD and then we set our RGB values. The RGB values themselves are in the display.hpp file. On line 12, we go ahead and define our print LCD function. Note that the signature is the same with what we have in our display.hpp. And then lines 13 through 17 define the function the same way we did previously. But now we've modularized our code. So we can go back to our initial file and we can update it. On line 1, we include our display.hpp. We don't need to include display.cpp. Within our setup, we do two things. We mention our namespace, which is display, and then we call the initialize function, and that does what we expect it to do. And then on line 5, we call the printlcd function, and then we pass in the parameters as we did previously. Next, we can confirm that our microcontroller is connected, and then we can go ahead and upload our code and keep an eye on the output screen. And that's it. Once it prints out done uploading, it behaves exactly the same way, but now the code is modular. Thank you. In this exercise, we're going to connect our Arduino Maker board to the LCD and to an accelerometer. Now, the accelerometer I'm using comes on this Arduino sensor kit. And it's this one here that I'm working with. Typically, I can break out all of the sensors, but I've chosen not to do that with this, just so that I don't misplace them. Right, so let's look at our wiring setup first of all. So this is our Arduino Maker, Wi-Fi 1010. And again on the side, we have our pins labeled. We have our VCC and our ground, those supply power. And then remember, we're working with SCL and SDA, so pins 12 and 11 respectively. Now you'll notice that I have this black and red pair of cables that go out from VCC and ground. Okay, the red is connected to VCC and the black is connected to ground. Now if you trace this, you'll see that it comes to this breadboard, and breadboards can be a little bit finicky, but this is our breadboard and this is our red and black. Our red is connected to this red power rail and our black is connected to the black power rail, which you can see slightly better. This particular board has a rail that isn't connected from beginning to end, so if you want to make use of power on multiple sets, you have to connect them, and that's what I've done with these wires here. Right, now our second pair of cables here, we've got a brown and a red. The brown is connected to 12, which is SCL, and the red is connected to 11, which is SDA. You need to pay careful attention to this and not mix it up. So our brown is connected to 12 and our red is connected to 11. And these connect to our breadboard and they're connected here. Now, you might not see it clearly, but just note our brown and red. Our brown is connected to SCL. Okay. Our brown is connected to SCL and our red is connected to SDA. So what that means is the red needs to be connected where we have SDA here. Now, you've seen this cable previously, and when we bring it in to match it in, what you'll then see is that our white is SDA. So our white here for SDA needs to match our SDA here, which is red. And so what you'll see on this breadboard, and this is why we don't use breadboards for a long time, is that our red here matches our white and our white, and then the brown matches all of our yellows. Once you get that setup done, you can then go ahead and connect your other DuPont cables. Okay, so we have this, and we have this, which is connected here to our accelerometer. Right. And then we can go ahead and connect the power to our microcontroller and put it on. And once our microcontroller is on, you see this Accelerator demo open serial monitor. Okay, if I turn off the power, it goes off. Put on the power, give it a second, and it comes back on. And that's it. Right, so now we can go over to our serial monitor and see what's going on. And while we're there, we'll also look at the code. So we're going to be working with the accelerometer, and that's the LIS. What we need to do is go in and search our library for the LIS 3D. And so we'll go to the library, and I already have the LIS 3D HDR highlighted. And this is what you need to install if you don't have it installed. And once we have that, now notice up here that our code is modular. The code for our display remains the same, and that's the point of the modularity. And all we have to do is add the code for our accelerometer. Now, let's look at the header file for accelerometer. On the first line, what we do is just put in the instruction for this header file to be included only once, and then we also include Arduino.h. And then we define a namespace, which we call Accel, and then we define 5 functions. We have an initialize function, and then we have a function called LIS available, which returns true or false. That just tells us whether or not we have an accelerometer to work with. And then we have 3 additional functions on lines 8, 9, and 10 that get the acceleration value on the x-axis, on the y-axis, and on the z-axis. So let's go ahead and look at what our definition looks like. At the very top, we need to include 3 libraries, our header file, first of all, and then the library for working with the accelerometer, and then we need to include wire.h. Within the namespace, we create an instance called LIS, and then we define wire. And this lets us do I2C communication. Then next, we have our initialize function on lines 10 to 15. And in there, we initialize LIS, so we call lis.begin. And then we have a delay of 1/10 of a second. And then we set our output data rate, which is 50 Hertz. These details you can get from the technical docs. For our own debugging purposes, we can print out that the accelerometer has been initialized. Then we have our LIS available, which just checks whether we have LIS. If we do, then we return true, otherwise we return false. On line 24, we have the definition for get acceleration x, which is acceleration along the x-axis. And that just is a wrapper for us to call lis.getAccelerationX. The next 2 functions do the same thing. So let's go back to our main file. And in our main file, we have our setup. We initialize our serial. We set it to a baud rate of 115,200. And then we initialize our accelerometer and our display. Now, if the accelerometer is available, then we print out on the LCD Accel demo, open serial monitor, and we've seen that in the demo already. And what that does is it lets us read what's being printed to the serial monitor. The rest of it is just saying if the accelerometer is not available, then we should print out Accel demo couldn't start. And so we know that there's a problem. Once this starts, we can start to read our values. And we see that from lines 21 to 28, where we put in what we want to do in our loop function. And what we're doing in our loop function on line 22 is we're printing out the X value. On line 23, we just put a tab space. On line 24, we get the Y value. Line 25, we put in the tab space. On line 26, we get the Z value of that acceleration, and then we delay for a second. Now, we've already uploaded this sketch. If you haven't already, you can click on upload to compile and then upload your sketch to your microcontroller. Now, once you have your setup all done, you can then go over and open the serial monitor. And when we open the serial monitor, because our accelerator is at rest, what we see is the X and Y values are pretty constant and the Z value is pretty constant. The only difference is that the Z isn't at 0, but the X and Y tend to be at 0. I'm not moving the accelerometer at this moment, but you can see the values changing. And we can also open a serial plotter, and I'll just drag that over here and leave it on the screen. And you can also see our values. So you can see that there are 3 colors: blue, red or orange, and green. And everything is pretty smooth. I'll go over now and move our accelerometer for a few seconds. And so you can see all the jiggly lines that were a result of the accelerometer being moved. And that's it. Thank you.